Okay, so for this part, we're getting ready to do all the other operations we got to do with trig, with sine, cosine, tangent, all those different things. But before we do that, we've got to back up and this was something that kind of got skipped over in PLP. So this was rationalizing a denominator. And I want to show you this now so that when we get to the worksheet that we need to get to, this will make things a lot easier when it comes down to it. So, all right, so for rationalizing the denominator, here's basically what we're going to do. When we talk about rationalizing the denominator, this means that you're going to remove the radical in the denominator. That it's not a big deal now with everything we have with computers and all the things we can do. But used to, if you had a square root in the denominator, it made doing the math really complicated. It's not near as bad now as it used to be, but it's still, it's a little bit easier if you don't have a radical that's in the denominator. So basically, here's what we're going to do. And we'll kind of walk this in. That if we have a problem that's like this, if we have 1 over the square root of 2, that to remove the radical in the denominator, all you're going to do is you're going to multiply the numerator and the denominator by the radical. Now, and it's the radical that's in the denominator. And we're going to kind of go through the steps on this the long way, and then we're going to show you the shortcut just so you can kind of start taking the shortcut on this thing. Okay, and we'll start with something really easy. We'll show you some. And again, they're not going to get real super complicated, so these we won't have to get into them a whole lot for this thing. All right, so if you have a problem, let's say we're doing like 1 over the square root of 2. If it asks you to rationalize the denominator, here's basically what we're going to do. We're going to take that 1 over square root of 2, and you're going to multiply the top and the bottom, numerator and denominator, by the square root of 2 that's in the denominator. Okay. On the top, we get square root of 2. On the bottom, you get square root of 4. And then whenever you do that, here's what you want to see. That if you do that, in the bottom, you've got square root of 4. Well, that's just 2. Yeah, so that becomes square root of 2 over 2. Yeah, and that's all you have to do. You just have to get the square root out of the denominator. So if it's in the numerator, it's fine. But the denominator just needs to be a number without a square root on it, is really what it comes down to. So if it was 7 over the square root of 3, to rationalize it, you would multiply the top and the bottom by square root of 3. Make it 7 square root of 3 over square root of 9. But when you take the square root of 9, that becomes 3. Okay, and then once we did enough of these, and again, we should have done this a while back, but with PLP, it kind of got glossed over. I think we missed this one because I don't remember us going through this, or if it did, it was a little bitty blip, and then we just kind of quick and moved on with it. Here's basically the shortcut for this thing. You're going to move the square root of the number to the top. So like we were doing 7 square root of 3, well then the answer, we move the square root of 3 from the bottom to the top. And on the bottom, so shortcut is you're going to move the square root of whatever the number is to the top, and you're going to leave off the square root on the bottom. And it's not a huge square root, but when we start doing things, sometimes it's going to speed up the process a little bit. So, if we were doing 5 over the square root of 7. Well, if we do the shortcut, again, we're going to move the square root from the bottom to the top. And on the bottom, you just leave off the square root and give me just the number. So it's 5 squared is 7 over 7. And most people go, okay, I kind of like that, because we don't really have to do it. If you do it that way, you don't really have to do any math. And most people are like, well, we're doing the math. We're doing this. But really, when we do this, that's all we're doing. So we're moving the square root from the bottom to the top. And on the bottom, you just leave off the square root. Just give me the number. Okay, now where that's going to tie in with what we're going to do today, and we'll kind of use this to kind of walk us in here, is that we're fixing to do some problems here in a minute where we're going to have something like this, where we're going to have 1/2 over square root of 3 over 2. And what we're going to do for this part is first thing is we would rewrite this as 1/2 times, divided by square root of 3 over 2. And I know we've talked about this a few times. Hopefully everybody remembers that if you have a division problem with fractions, then what you can wind up doing is you can do KFC, right? Keep it, change it and flip it. So you're going to keep the 1/2 the same. You're going to change the division to multiplication, and then you flip this number upside down. Okay, everybody remember doing KCF?
So after you do that, would you have to go back and do
So the 2's would cancel. That leaves you with 1 over the square root of 3. But now that you get this answer, it's kind of like what we're doing back up here. Well, this answer has the square root in the bottom. So now we've got to rationalize it. And to rationalize it again, what we're going to do is we're going to, we've still got the one top. We're going to move the square root of 3 from the bottom to the top. And on the bottom, we take the square root off and leave just the number. And since it's 1 times the square root of 3, we'll just leave the square root of 3 over 3. Okay, so when we talk about rationalizing the denominator, that's really what we're doing. And again, you can go through the steps and talk about doing the work with it, but the shortcut is if you have a number that you get here and need to rationalize it, you move the square root from the bottom to the top, and on the bottom, you just take off the square root and leave me just the number. Okay, so if that sort of makes sense, that's as bad as when we go through everything. That's what we kind of have to get through. That's the hard part of what we're going to do today. What we're going to do now is let's kind of back up and show you what we're going to do with the rest of it. That's where y'all can go back to the sheet that I gave to you earlier. That we're going to go back and show you how to use this thing and what this comes out to be. So 2 things. You need this sheet and you need your unit circle. Okay, now as you start working through the homework, if you start going through some of the problems, it's not going to be a chart quite like this, but this was the easiest way to kind of get the idea, is that some of these problems they're going to ask you to find. I'll move this one out of the way. That instead of being a big table like this, they're going to ask you to find the cosine of pi over 3. So I made this chart so that, okay, if we're doing this one, this will be the cosine of pi over 3. We're going to put this answer here. If we did the sine of pi over 3, we're going to put this answer here. But if it was just one problem at a time, they're going to basically do this. They're going to say, all right, find the cosine of pi over 3. And just remember, when we do cosine and sine, cosine is your x value and sine is your y value. So if I ask you to find cosine of pi over 3, here's all you have to do. On your unit circle, you find pi over 3. If I ask you to find the cosine, you tell me what the x value is. And that's all you have to do. Just tell me it's 1/2. So on our chart over here, we're going to put 1/2. Okay, and then same thing on this one, is that if they ask you to find the sine of pi over 3, you do the same thing. You go to pi over 3 on your number chart. Sine is going to be the second number. So it's square root of 3 over 2. So on our chart here, we're going to put the sine of pi over 3 will be square root of 3 over 2. And most people go, so is that all we're going to do for cosine and sine? Yes, for cosine and sine, that is all you have to do. Is you're going to look on the unit circle and tell me, all right, what number is that on the unit circle? So when we go to pi over 2, same thing. if we have to find the cosine of pi over 2, that's going to be the first number, so that's 0. And the 1 is the second number. So we're going to put 0 for cosine, and we're going to put 1 for sine. And then hopefully you start to make the connection that, okay, when I'm doing this thing, the ordered pair then is just the answers to this number. Yeah. So when you go to pi over 2, this is going to be the cosine, and this is going to be the sine. When we go to 2 pi over 3, this is going to be the cosine, this is going to be the sine. And that's the connection you've got to make, is that when we do all these things, cosine and sine is just finding those numbers on the ordered pair that's on your unit circle. So for pi over 6, this is going to be cosine, this is going to be sine. And just putting those numbers in to know that, okay, if I do cosine of pi over 6, that's the first number. If I do sine of pi over 6, that's the second number. If you go to pi over 4, both answers are square root of 2 over 2 and square root of 2 over 2. Okay, if we go to pi, it's negative 1, 0, so cosine is negative 1, sine is 0. If you go to 330, that's right here, that's square root of 3 over 2 and then negative 1/2. -45 degrees. Now this time it's negative 45 degrees. So for this one now, if you notice that negative 45 is not on here because all these numbers are positive. So if you need to find negative 45, that's basically where we're going to do like we did earlier. You're going to do negative 45 plus 360. And if you do negative 45 plus 360, then that's going to put you at 315. Now, and the way you can kind of look at it on the graph too is if it's negative 45, that means on this angle you're coming down 45 degrees. That if you start at 360, you could do 360 minus 45, and that would put you at 315. So you can kind of look at it that way too. So that's basically the number that we would use here. So negative 45, that's the same thing as 315. So that's square root of 2 over 2 for the cosine and negative square root of 2 over 2 for the sine. Okay, negative 7 pi over 6. And again, most people go, all right, still not good with the radians, and that's fine because it takes a while. Honestly, it's one of those things that about the time we get to the end of this, that's when you'll finally start to feel comfortable with the radians, because it'll take a week or so before it kind of sinks in. So in the meantime, what you'll do is you'll just look at it. So, all right, well, 7 pi over 6 is 210. So this is the same thing as negative 210. And if it's negative 210, to figure out and again, negative 210 is not on the list. So basically, again, we're starting here at 360. And we're going to do 360 minus 210, which would put us at 150 degrees. So negative 210 would be the same thing as being a positive 150. So that's going to put us right here. So it's going to be negative square root of 3 over 2 for the cosine and then 1/2 for the sine. Okay, and that's where we did that whole working around the circle. If they give you a negative number, if you need to know what it is, just add 360 to it. Or if they give you a number that's too big, if it's 720, well, if you subtract 720 and 360, that's going to get you back to 360. So 360 or 0, it doesn't matter, 1. That's going to put you back here. That's going to put you at 10. All right, now the very last one. This is where you have to get a little bit creative, and I'll show you on this one on the unit circle how to get there, because 13 pi over 2 is not on the list, nowhere to be found. But here's kind of what you have to do. The only thing that's the biggest number we get that's pi over 2 is way down here. That's 3 pi over 2. The only other pi over 2 we have is up here. So basically this would be 1 pi over 2. But here's kind of what you can look at it. If this is 1 pi over 2, and that's 90 degrees, it'd be okay if we did 2 pi over 2, we could cancel out the 2's and just make this pi. We've got 3 pi over 2 here. So what if we did 4 pi over 2? We cancel that out, make that 2 pi, right? So if we keep going around the circle, this is 1 pi over 2. That every 90 degrees is 1 more pi over 2. So this would be 1 pi over 2. This would be 2 pi over 2. This would be 3 pi over 2. This would be 4. And if you want to keep going, you just keep counting. This would be 5, 6, 7, 8, 9, 10, 11, 12. And then 13 pi over 2 would eventually put you right back here. So we'll use 0 and 1. Okay, so if they give you something that's pi, it's way too big, and you're like, okay, that's not on the list here. That's one option you can do. The other thing that I kind of, once I started doing these and figuring out that I kind of like to do, was I just divided the 2 into 13 and figured out that was going to be 6 with 1 left over. So this was going to be 6.5 pi. And people are like, well, yeah, but 6 pi is still not on the list. Okay, it's not. But if this is 1 pi over here, this is 2 pi over here, that if we kept going around, that pi is 180 degrees. So every time we go pi, that's 180 degrees, that's another pi. So this would be 1 pi. This would be 2 pi. If we went another 180, this would put us at 3 pi. This would be 4 pi. This would be 5 pi. This would be 6 pi. So basically, you know, you can think about this as being 2 pi. This would be 4 pi. This is 6 pi. It's any even pi would put you back here. Any odd pi would put you back here. And you're like, what about the half? Well, if we went 6 pi's, that would put us back here. We need 1 more. That's going to be pi over 2. Well, then we go up to pi over 2, and that would put you back to here. And so it doesn't matter how you get there. If it's a bigger number, that just means you've gone around the unit circle an extra time or 2, or maybe 3 or 4. So it's just realize that the numbers are going to keep repeating. You just got to eventually work around to get to where it is that it stops on that unit circle. Okay, so is everybody okay with what we're doing here for the cosine and the sine? That again, cosine is just, you go to this number, cosine is the first, it's the x coordinate, sine is going to be the y coordinate. All right, now here's where we're going to put it all together. Here's where we do the rationalizing. Here's where we're going to put everything together. When we do tangent, now here's the big thing you have to kind of connect on and see. That everything else back here, when we do tangent or secant or cosecant or cotangent or any of this other stuff, it's all based on these 2 answers. And for tangent, what we did yesterday was we said tangent was going to be sine over cosine. So on this very first, and we won't do this on all these, but on this very first problem, if they ask it, it would be tangent of pi over 3. Which means when we go to pi over 3, we need to put sine on top, we need to put the cosine on the bottom. So that's square root of 3 over 2 over 1/2. Okay, so sine's on top, cosine's on the bottom. And then that becomes that problem that we were doing back here, where if we've got one thing over another, we're going to keep it, change it, and flip it. Now, I'm going to show you a little shortcut on this one, too. When you go keep, change, flip on this one, you're going to keep the top number the same. You're going to change this big division bar to multiplication, and then the bottom fraction, that's the one you're going to flip. So that makes it square root of 3 over 2 times 2 over 1. And that way we can save a little bit of space, make the work go a little bit faster. So it's going to be keep, change, flip, just straight down the page. The 2's will cancel. You get square root of 3 over 1, but if it's 1 on the bottom, it doesn't matter. That's just a plain old square root of 3. Okay, now, some people say, well, are we always going to do that much work to get tangent? No, because here's one where you're going to get a really quick, short answer. Because again, tangent, if we were doing tangent of pi over 2, that means we need to do sine over cosine. That's 1 over 0. Okay, now here's the 10-cent question of the day. Do you remember what 1 over 0 is? It's either 0 or it's undefined. And if 0 is on the bottom, it's going to be, if you're not sure, guess what you do? Check it on your calculator. Do 1 divided by 0. And that says, can't divide by 0. That's an error message. That means this thing is undefined. So again, if you get to this point, if you get zeros and ones, just go back in and check it. And if you're not sure, just do a quick double check to make sure you get what it is that you need to do. Okay, so now here's where we're going to save a little bit of work with number 3. Because on number 3, if we do tangent of pi over 6, that's going to be 1/2 over square root of 3 over 2. So this would be where we would keep it, change it, and flip it. So that's 1/2 times, flip this one upside down, make it 2 over square root of 3. We keep it, change it, flip it. The 2's cancel, we get 1 over the square root of 3. But that's the same problem we had back here, right? Where we got to go back then and rationalize it. So if we already kind of did it back here, and we did this problem, and we figured out if we did 1 over square root of 3, there again, we're going to move the square root of 3 from the bottom to the top and take the square root off the bottom. There you go. There's your answer we're looking for. And for these problems, that's the hardest thing you have to do, is to rationalize. And here's the part, here's the cheat sheet part that you get. When we do these, every answer that you're ever going to see when we have to do this work in Math Excel, you've got every answer right here on this paper. So you don't have to worry about doing anything. You can just look at this, and this is going to be your reference sheet that you can go back and check on. Okay, number 4. This is going to be really good. Y'all going to like this one. What happens when you put the same thing over itself? Yeah, you just get a 1. It's that easy. That's all you got to do. All right, number 5. If we do tangent, it's 0 over -1. If 1 on the bottom was undefined, sorry, if 0 on the bottom was undefined, 0 on the top means the answer is 0. Okay, now here's where life gets really good. You know, as good as it can get in math class. When you get ready to do number 6, we're going to do sine over cosine. It's -1/2 over square root of 3 over 2. But here's what we want you to catch and see. Because once we do this one, hopefully that's where the little bells are going off in your head, and you're going, wait a minute, wait a minute, wait a minute. I did 1/2 over square root of 3 over 2 right here. It gave me this answer of square root of 3 over 3. If I've got the same thing right here, guess what the answer is going to be? It's going to be square root of 3 over 3. The only difference is now we've got one negative and one positive, so the answer is going to be a negative. And people go, oh, so you mean once I do this, I don't have to keep redoing these problems? I can just look at my old answer? Yes, go back and look at your old answer. And that's what this sheet's going to do. That now that we've done this, you don't have to keep recreating the answers. You just look on here and you find out, okay, there's 1/2 square root of 3 over 2. That answer is square root of 3 over 3. The worst thing you have to do is you may have one negative or you might have two negatives to put in, but it's just going to change the sign, but that's the worst thing you have to do. So when we do number 7, it's negative square root of 2 over 2 over square root of 2 over 2. It's the same thing over itself, which is 1, but it's a negative divided by positive, so that makes the answer a negative. There you go. And then you look at this one, you're like, oh wait, well this is the same thing as this one, and I've got a positive divided by negative, so this answer is going to be the same as this answer. Yeah, it's still negative square root of 3 over 3. Okay, when you do this one, it's 0 over 1. Same thing we had here. 0 on top, doesn't matter what the bottom is, it's still 0. And this last one, if you do 1 over 0, that one is undefined. Okay, and that's the big thing we want you to see on this one, is that when we're doing sine and cosine and secant and tangent, all this other stuff, that there's really only just a few answers that you can do for this thing. Okay, so what we're going to do then is we're going to do one more column here with secant. After we do secant, then we're basically kind of done everything that we have to do, because after we get this group of answers here, we've got every answer we could ever possibly need from everything, from these two columns that we've got right here. So for secant, this is going to be 1 over cosine. So when we're doing this part of the problem, we can just take everything else that's here, that's not cosine, and just cover it up because we don't need it. Because when you do secant, you just need the cosine. And secant is 1 over cosine. So when you have for the secant of pi over 3, that's going to be the same thing as just 1 over the cosine of pi over 3. And the cosine of pi over 3 was 1/2. So this is 1 over 1/2. And with every single one of these, you're going to do a keep, change, and flip. The good news is that the first part's always 1. Change the division, multiplication, you flip this upside down, it's 2 over 1. So that's just 1 times 2, which is just 2. If it's just a number like that, not really. I mean, this is just kind of me showing you the steps on it, but obviously once you get here, you can shorten this thing up a lot. Okay. All right, when we do this one, this is a lot better. This is the secant of pi over 2, so we need 1 over the cosine. Well, that's 1 over 0, and we had that part right here. That's just undefined. Okay, now here's about as bad as it's going to get when we go through these. If you can get this one, then you're in really good shape. When we do this one, it's 1 over cosine. So if we do the secant of pi over 6, it's 1 over cosine. Cosine is square root 3 over 2. Again, if we keep it, change it, and flip it, that's 1 times 2 over the square root of 3. You're like, well, 1 times doesn't change anything, right? So it just makes it 2 over the square root of 3. But for that problem, we've got a square root in the denominator. So, and I wish this box was just a little bit longer. So for this one, we've got to change it. We'll go ahead and stretch it out here a little bit more. You've got to rationalize it, which means we've got to move the square root from the bottom up to the top. And on the bottom, you take off the square root and give me just the number that's there. Okay, now what I'm going to do for this part is I'm going to go ahead and fold this back so that we can take out the tangent part. Make it just a little bit shorter here. And that way you can see the secant part and the cosine part without having to do anything else with it. All right, so I'm just going to cover up this tangent part for just a minute, just so we don't have to see everything that's there. That way we can see what we need to be. And this is almost one of those, if you were doing a problem like this, you could almost just kind of pull this thing back and just even cover up the sine part. Because all we need is that one number that's with cosine. So for doing this problem, that's all we need. We just need that one piece that's right there. That we're going to do 1 over this number. So anytime we're doing secant, it's just 1 over the cosine. So that's 1 over the square root of 2 over 2. And again, if we do keep, change, flip, that's 1 times 2 over the square root of 2, which is really just 2 over the square root of 2. And again, if we rationalize it, we're going to move the square root of 2 from the bottom up to the top. And on the top, we're going to take off. So we move the square root of 2 from the bottom to the top. On the bottom, we take off the square root and leave the 2. And since you've got 2 over 2, you can cancel out those 2's and make it just square root of 2. Okay, now I realize we went in the cosecant here, but that's fine because we won't need that part for later for what we're doing. Okay, next one really easy. It's 1 over -1. All right, that's pretty straightforward. That's 1 over that one. And here's what I want you to see. When you start going through the rest of them, the next problem down, we're going to do 1 over the square root of 3 over 2. But here's what I want you to look at. We did that one right here. These two answers have got the same numbers, so we don't have to do all this work. We just need this answer that's right here. That's 2 square root of 3 over 3. Okay, so just like when we were doing tangent, all these numbers, all these answers kept repeating and popping back up. Same thing with these. Once you've done a couple of the different secants, the same answers keep popping back up. For this one, it's square root of 2 over 2. That's the same thing we've got right here. This answer was square root of 2. So we already know that this answer and this answer have to be the same because it's the exact same number. When we get down to the next one here at number 8, square root of 3 over 2, the only difference is this one's negative. So this answer is going to be the same thing. It's just going to be a negative. This one's 1 over 1, so that's just 1. This one's going to be 1 over 0, which was undefined. So it just keeps repeating. So once you've got a couple of different answers, once you've done a few answers, it's the exact same answers. It just keeps repeating over and over and over and over and over when you go through these. And that's why it's kind of good to have this sheet. So now that you can do this one, you don't have to keep redoing the work. You've got this little cheat sheet that all you have to do is look on here and go, oh, well, if I need 1 over square root of 3, there it is right there. You can see that on the paper. Here we go. There's 1 over square root of 3 over 2. We'll just do that. And you can actually, we'll make a little cheat sheet here in a second. So we'll show the shortcuts on these, that if you get this answer that pops up when you're doing it, this is what the answer is going to be, so that you can kind of make quick work of it. The only thing that's different about cosecant is that instead of if we did secant, it was 1 over cosine. If we do cosecant, that is 1 over sine. But here's what I want you to see when we do this. We're only going to do a couple of them, because once we do a couple of these, you'll be like, well, hey, that's the exact same thing that we were doing. Yeah, it is. That if we can get to, pull this back here. Do this part. We're going to leave the secant on for this one. When you do cosecant, it's 1 over sine. So for the very first one right here, this is 1 over the square root of 3 over 2. Hey, look, you got that answer right here. There's 1 over square root of 3 over 2. This answer is 2 square root of 3 over 3. So every answer that's in cosecant is going to be the same thing. It's the same list of answers as if it was secant. So the only difference on these two answers is it's just depending on where the problem is. It's the exact same set of numbers. This one is 1 over 1, so that's still just 1. If we did cosecant on this one, this was 1 over a half. We did 1 over a half. Where did we do it? Oh, right here, the very first one, right? This was 1 over a half. So this answer was just 2. This answer would have also been 1 over the square root of 2, because both of these numbers were the same numbers. So when you do the secant or the cosecant, it's still going to be the exact same number either way. So both of these answers were square root of 2. This one's 1 over 0. That's undefined. So it's the exact same answers, just keep popping back up. So when you do these, don't keep working out every single one of these. Just make a little list, and then once you've got the list, you've got everything that you need to get the answers on this thing. Same thing with the next one here, number 6. This was 1 over negative 1/2. Again, we had that one right here. This was 1 over a half. It was 2. If you make that number negative, this number is just negative 2. You know, this one, same thing. It's going to be the exact same number here. It's just going to be a negative. You know, if we do 1 over a half here, well, again, we just did that problem right here. It's the exact same answer, but this time it's positive. So it's just the same answers, just repeating over and over and over and over. So you don't have to keep recreating the wheel on this one. Just keep this little list that you've got, and you can keep coming back to it. Okay, here comes the magic for cotangent at the end. And we're not going to do the last couple because, again, it just keeps repeating the same answers here. And here's the last thing I want you to see for cotangent. When you do cotangent, you've already got all the answers that you need, because cotangent is cosine over sine. And once we write down the numbers, we're going to look back at tangent, and you're going to go, oh, well, there's that answer right there. I've got it. So everything that's in the cotangent column on the last one, that's going to be the exact same thing of everything that's in the tangent column, and I'll flip back over here in just a second. Okay, so when we're doing this one, I'll zoom this out just a little bit because it's just not quite big enough. That should be good. Okay, so if we're doing cotangent of this number, and again, if you're doing cotangent, we don't need secant or cosecant, so it's almost one of those that we can just kind of fold this over and get it out of the way, because we do not need anything there. So we can kind of cover up the secant and the cosecant, because we don't need anything with that one. Because cotangent is cosine over sine. So for the very first one right here, if we do cosine over sine, we're doing 1/2 over the square root of 3 over 2. But if you look at this answer, that's the same answer we've got right here. Here's a 1/2 over square root of 3 over 2. Answer square root of 3 over 3. So all these answers are here. They're just in reverse order of all the answers that we already have here. This one would be, just flip these two numbers upside down. This would be 0 over 1. All right, well, that's just 1. When we do this problem, cosine is square root of 3 over 2. Sine is 1/2. If you, oh, sorry, thank you. I said the wrong thing, didn't I? Yeah, so it's, well, that's right, isn't it? Cosine over sine, 0 over 1. Yeah. Oh, sorry, got you at the end there. Okay, my bad. Thank you. All right, now I see. Yeah, 0 over 1 is 0, not 1. My bad. Bad teacher. Okay, when you check this one, square root of 3 over 2 over 1/2, we've got that number right here. That is square root of 3. So every single answer as we go through here, if we've got this list with tangent, we've already done all the work. All we got to do is just pull over the answers. This one is still same thing over itself, so this one would still be 1 because we reversed the order.